Hey y'all, this is Longo and we are going to talk about parabolas in this video. So, what you need to know is you can open up, down, left, or right with parabolas. I know by now you've probably only focused on the up and down ones. We're going to talk about all four directions. So, if x is squared, this is old school, you know this, x squared is a parabola that opens up, negative if it opens down. If we have y squared, though, if it's positive, we're going to open to the right, and negative, we're going to open to the left. So, just like everything else in this unit, it's easier once you see it. This is just to discuss. So, in both equations, we have our x minus h, and we have our y minus k. Your vertex is still h and k, but we have 4a in both of them. If the 4a is negative, that's going to open down or left. If the 4a is positive, that's going to open up or to the right. A is the distance from the vertex to the focus and the directrix. Okay? Your focus is always inside the parabola. The directrix is always outside of the parabola. And then you have a latus rectum, which is the width of the parabola at the focus. Okay? So there is a lot of stuff going on here that is much easier to understand if we just go through the motions. So, vertex is h comma k, x comma y, -1, comma 3, because we have to have the -1 with the x and the 3 with the y, because that's where it comes from in the parabola's equation. So remember what I said, a is the distance. So what we're going to do here is we're going to take 4a, and it's equal to a -8, which means a is technically equal to a -2 when we're solving, but it's a distance, so it's just 2. Okay? Just so you are aware when you are listing this. Now, we cannot really go place that dot yet. I mean, we can. We can do that, but we're going to just find a few other things as we go. So what we need to do is figure out if this is opening up, down, left, or right, okay? Since this is a positive, or this is an x squared, but it is negative. This is a negative x squared. This is going to open down, okay? So we're going to just kind of open down. But we're not going to draw it perfect yet. So let's go find our focus. Our focus is 2 away from the vertex. That is down inside of the parabola. So we are going to go down 2, and we're going to put a focus. That is at -1, comma 1. And our directrix is outside of the parabola. So we have to go 2 above. Now, here's the thing about a directrix. It is a line. It is a horizontal dashed line. It's actually perpendicular to the direction that it's opening. So if this is opening down, it's going to be left to right. If it was opening right, it would be up and down. It's going to be on the outside, okay? So our directrix would be y is equal to 5, because we learned that horizontal lines have y equals because it goes through the y-axis at 5. Okay, so now we have to find the latus rectum points, and that's where things get a little bit tricky. The latus rectum points is the width at the focus. So this 8 right here, the 8 is how wide it is at the focus. That means if you split that in half, you're going to have 4 and 4. So you need to go 4 to the right of the focus. 1, 2, 3, 4. And you put a dot. And you go 4 to the left. 1, 2, 3, 4. And you put another dot. So remember, that first parabola I drew was just to help you get started. So you knew that it was opening down. Then when you put in your latus rectum points, it's going to make it much easier to graph. So those points are a -5, 1, and 3, 1. Okay? So that is how you do a parabola. Now, of course, we can go up, down, left, and right. That was an example of opening down. You do the exact same thing if you open up, except for your focus would go up and your directrix would go underneath. Here is an example that goes to the right and to the left. So as always, pause the video if you would like to give this one a try on your own, and then click play when you are ready to watch it go step by step. So here we go. We have a vertex of 5, -2. So remember, the 5, -2 is because the 5 goes with the x and the y goes with the 2. So you have to be careful. So if we go to 5, -2, we are going to be starting right there. Now again, this is y squared. It's positive, so this is going to open to the right. So just like we did in the last one, think right, but that's not your graph yet. Let's go find our a value. 16 is equal to 4a, so when we divide by 4, we know that a is equal to 4. Remember, a is a distance. We don't need to put a positive or a negative. The distance, or a, is 4. So that means it is 4 inside. 1, 2, 3, 4 to the inside. And 1, 2, 3, 4 to the x, or to the left on the outside. But that is a vertical line because it has to be perpendicular. So our focus is at 9, -2. And our directrix is at x equals 1. Okay? So now to help us graph, we have to go find our lattice rectum point. So remember, the width at the focus is 16, which means we split that into 8 and 8. So we have to go 8 below at the focus, and we have to go 8 above at the focus. And now you can give yourself a nice sketch of the graph. So we are going to have a big old thing like that. And of course, our LR points are 9, 6 and 9, -10. Okay? And that is it with parabolas, y'all. So that concludes our conics unit. This is Longo, and I'm out. See you, bye.